Today's lesson is about expected outcomes. The expected outcome is the number of times an event is expected to occur after a number of trials. This is calculated by the probability times the total number of trials. So, easy way to think about it, if I have 4 children, I would expect that 2 of them would be boys and 2 of them would be girls by their probability. The reason for that, there's a 50% chance that a baby is a boy or a girl. So we'd expect that 50% of our children would be boys, but the other 50% would be girls. However, we know that that's not the case in reality because not every 4-child family has 2 boys and 2 girls. So if we think about again how we do this calculation, we're going to have a look at some example questions. So the first one, relatively straightforward one. If a coin is flipped 80 times, the expected number of tails will be, and I think most of us can think of the answer straight away because the probability is well known of getting a tails. The probability of getting tails is equal to 0.5 or 1 out of 2. Remember, we should write our answers as decimals as they're easier to calculate rather than using fractions. So that's the probability sorted. The other thing we need to think about is the total number of trials, which is 80 in this case. So the calculation becomes really easy to write. So the expected number of tails is equal to 0.5 times 80, which is equal to 40. However, our answer isn't finished because we haven't given our answer in context. So there, I would expect 40 tails from flipping a coin 80 times. It's really important you do that. It makes it that we're actually answering the question. So moving on to example 2. A die is rolled 30 times. So straight away we can write in the trials, which is 30. What is the probability of getting a number greater than 4? Now that's not something that comes straight to me, so I need to think about how do I work out the probability of getting a number greater than 4. So I have to think about all the possibilities. 1, 2, 3, 4, 5, 6. And which one of those numbers are greater than 4? It's 5 and 6. So it's 2 out of 6. 2 of the outcomes out of 6 possible outcomes are greater than 4. So that can be shortened to a third. If we're making it into decimal, 2, 3, 3, 3. So then going back to the expected number, that is 0.333. So we have to times that by 30. So the expected number is equal to 0.33 times 30, which will give us answer 10. So remember to answer your question in context. I would expect answers greater, 10 answers greater than 4. So for our third example, the previous examples have been about probabilities, about things that we're fairly familiar with, like die and coins. Real power of expected numbers is looking at things that we know that we aren't so familiar with, to then try and put it in a perspective or with a certain population or a number of trials that can make it a bit more real to us. So the next one is a bit more real world. It's how many babies would you expect to be born with extra fingers or toes next year? So we haven't been given all the information to start with, but we do need to know what is the probability, first of all, of a baby being born with extra fingers or toes. And the next thing is to know how many trial or how many babies there were born in a particular year. Now, we won't know about next year, but we can only compare it to a previous year. So we know that from past experience that the probability of a baby having extra finger or toe is 1 out of 500. Now that number is not particularly useful for us for our calculations, so we have to convert it to a decimal. So we can convert it to a fraction to start with, 1 in 500. And then if we change that to a decimal, we end up with 0.002. So the second part is we need to know how many babies were born in total. Now, the great thing is we can look this up from the census or from records and things like that. There was 58,020 babies born in 2018. Now, it sort of brings up the questions about next year. Well, no way we can tell how many babies were born next year. We can only go on a past year. And in most cases, the expected numbers are going to be wrong, but they are only for us to get an indication based on the probability. A bit like probabilities, really. They're only based on information we have, and certain things can change a probability quite drastically. So the next thing we have to do is work out the expected number of extra fingers and toes. And what we need to do is take the probability, which is 0.002, and times it by 58,020. When we do that, we end up with, we can do that on a calculator, 116.04. Now, that brings us to an interesting answer. Because we're talking about babies, or the unit that we're looking at is babies, we can't really give an answer with 0.04. Now, normally, and in most cases, rounding normally is okay, so we'd round that down. But in this case, I'm going to actually round up. And the reason for that is that this is quite a negative. Not everybody wants a baby born with extra fingers or toes. So generally where there's sort of a negative outcome, we tend to try and round up or overestimate, so that if in reality we're more likely to then end up with an answer that's less than that, and then everybody's happy. Nobody's then complained we haven't got enough babies or we didn't predict enough babies with fingers or toes. If we go the other way, there's a chance that we underestimate that, and that could be a problem. So there's 117. We would expect every year 117 babies to have an extra be born with an extra finger or toe. Have a look back on your OneNote page and have a go at the questions in your workbook.